Welcome to this session of Shadow the Scientist. My name is Jamaica Marshall, and I serve as the Shadow the Scientist Programs Manager. Right. This session, we are going to be joining Dr. Viraja Katu at the Canada Francois Telescope for MegaCam Eyes Wide Open on the Sky. Now, um, if you've joined us before, then you know that Dr. Katu is usually joined by a remote observer. So we're waiting for that remote observer to join us uh, either in person or virtually, hopefully soon. But we're going to go ahead and get started. Now, Dr. Katu, I am excited to have you here. And before we go any further, I'd like to go ahead and share a different screen because I was checking on the weather, and maybe you can get us started by talking about talking about that because it looks I'm not sure what we say. I can barely see the Keck telescope. It's fog. Welcome, Dr. Katu. Welcome, dear.
Thank you so much, Jamaica. Thank you for that wonderful introduction. Hello, everyone. I am Dr. Viraja Katu. I am a resident astronomer here at the Canada France Hawaii Telescope. I am right now situated in our control room, which is in Waimea. Our observatory is up on the summit of Maunakea, which, as you can see from what Jamaica is sharing right now, it's totally covered in fog. That is exactly what we are seeing right now in all the cameras here. So we have to wait and see what happens in the next hour and a half till we go on with this event.
Oh, wow. Okay, so maybe this is a good place to start, Virja. So you're sucked in. There's fog. There's obviously precipitation,
Yes.
and water vapor in the air. What is the first thing that you, as an astronomer, need to think about if you're getting ready to open?
So the one thing that we want to make sure absolutely is that we are definitely not covered in fog. A lot of fog means there is a lot of water vapor. There is a very high humidity. So right now the humidity is kind of it is showing up in red on our screen. And let me share the screen so that I can show what I mean when
Absolutely.
I'm looking at the weather screens on our end and on the control software. So just give me a second. So this is a screen that shows our telescope control software. Right now, everything is shut down. Nothing is open for now. We're still expecting our remote observer to enter the room. So there is nothing that is open right now. And the boxes that I was talking about that show us the humidity is the one in red on the top right. You can see there's 93.5% humidity. That is much above the acceptable bar, which is roughly around 80-85%. So it is way too high. Nothing can be done at this point. We just have to wait, sit back, and assess the situation, what's happening up on the summit. So we are waiting for the fog to disappear. We are waiting for the humidity to go down below the limit, the upper limit that we have. We also want to make sure that there are not a lot of clouds. Sometimes if there are a lot of clouds crowding, then that may lead to fluctuations in the humidity, and we have to be careful about that before we open up. We definitely want once all of the main points are cleared out, then we want to make sure that there are not a lot of clouds, and we actually get patches of clear skies where we can actually start observing. So those are the major things that we are concerned about right now. If you really look at the satellite images, let me share another screen.
Yes, please do share another screen. And here we have a question really quick from
Sure.
Sven. So Sven says, I have a question. The feed is showing live from Subaru Telescope, Hawaii. That's what I was showing earlier for those of you who are just joining. Says, I know of the Subaru Telescope in Japan. Are there multiple Subaru telescope, or is Subaru a type of telescope? Well, first of all, the Subaru telescope. There is one here in Hawaii run by the National Astronomical Observatory of Japan. And Subaru refers to actually an open cluster of stars known as the Pleiades, or in Hawaiian, Makali'i, which means the little eyes. And so, yes, that live stream, I just put the link in the chat, is from Astro Asahi Live by the Subaru telescope. So I hope that answers your question, Sven. So now, Viraja, what is happening here? It looks like a lot of precipitation.
Yes, this looks like this is a lot of precipitation. If what we are looking at right now is the satellite image, and this is from the Maunakea Weather Center. And what you see over there is a more localized view of all the Hawaiian islands. You can see the bar, which is on the bottom, is really showing how much water vapor and how much flow of that water vapor is happening. So this is an animation, basically a simulation of how the water vapor is going to move across over the islands. And if you look at the plot down there, the ones which are more yellower or redder colors, those mean a higher concentration of all the water vapor. As you can see right now, the big island of Hawaii is almost like swamped with all the water vapor. So these are definitely not good conditions for observing. We just have to wait and see how the situation changes. But that's pretty much, so this is a satellite image. There are the webcam that Jamika shared earlier. There are all these different views of the top of the summit that we take into account when we are getting over here, thinking about starting up for the night. So with that, sure, Jamika, you have a question?
Yeah, so I was just going to ask, in these situations, so of course you have to wait a certain amount of time, I assume, as you're saying, because you can't open in these conditions. What is that time frame, and what do the conditions need to be like, and for how long before you can even consider opening the telescope?
So we we definitely want to have we definitely do not want to see any fog when we are looking at the webcams. We can easily make out whether or not we are seeing the fog. We have other sorts of screens up here, in our control room that show us the different views. So we don't want to have fog. And as I was saying earlier, the main concern with fog and with a lot of water vapor is the buildup of humidity. And we want to make sure that the humidity goes below the limit when it's acceptable for science observing, which is somewhere around 80 to 85% of relative humidity that we are considering. So as soon as the bar goes below, and the observer makes an assessment even at that point, that even if the humidity has gone down, how do the conditions look like? If it looks like the humidity might rise in the next 15 minutes or half an hour, then they cannot immediately make a decision about opening, because opening up is a process. It takes some time. They have to do assessments even internally inside the observatory, inside the dome, that there are no concerns about any leaks anywhere. And they want to make an assessment internally as well before they make a decision of opening up.
Now, with some of the different observatories that we are privileged to work with, like the International Gemini Observatory, I know that with Q observing, they have a range of programs that they can observe depending on many factors,
Mhm.
including weather. And they have poor weather programs. Does
Yes.
CFHT have something similar?
Yes, that's a great question. And with that, I would actually take a step back and explain a little bit about what the programs are and where do they come from. The trying to elaborate on the different categories of these programs. So there is a peer review process when the telescope proposals come in from astronomers around the world. In this process, there's basically a first phase of observing, a first phase of proposing for telescope time. Once the proposals are submitted, and these are written proposals, then they get assessed and they are ranked, and some of them are some of them are accepted for time on the telescope. So this is the at this stage they enter the phase two of the proposing cycle, where they are now accepted programs on specific telescopes, and they can now start scheduling their observations, so they can start defining their programs, how they want, what specific observations, which part of the sky, how much do they, what are the technical specifications and things like that. So once that is done, those programs are ready to be observed. But these programs at some observatories like the Gemini and CFHT over here, we actually do a Q service observing mode. The Q service observing mode basically means that we need not be physically located at the telescope when we are doing the observing. We are basically observing remotely, and we do that at CFHT here from our control room in Waimea. Gemini has their control-based facility in Hilo. And observations can be done remotely. They are basically queued for every night. That the name explains that it's a queue service observing mode. So all the every observation is put in a big queue, and there are different queues depending upon the different conditions of the night. Uh, so there is one main queue which has all the programs that need excellent observing conditions. So these are the programs that need, say, for example, really good seeing conditions. And really good seeing on Maunakea is we are talking about somewhere between 0.4 or 0.6 arc seconds. There are programs that need a little average seeing conditions when we are a little bit less than 1 arc second. And there are programs that can tolerate poor conditions. And by poor conditions, it means they can tolerate clouds. They can tolerate a little bit of a poor seeing. They can tolerate like passing cloud cover. They can tolerate a little bit of the moon. So these are the poor programs, poor condition programs. And then there's an additional queue for those programs. So if conditions are, say, for example, we are at 75% humidity and we are staying constant there, we still decide to open, then there could be programs that we can still do with that, with those kinds of conditions. And we are, in that way, we are not losing time for science. And that is the main goal of having those programs in different categories.
Oh, brilliant, brilliant. So now, Virja, if I may, I noticed that we have one of our other science hosts joining us. Can I invite them
Sure,
uh,
absolutely.
to
Yes.
turn on their video? Okay, so we have Erin Figura, who was the host of our session last night with the International Gemini Observatory. Erin, would you care to join us in turning on your video? Oh, I have a message here. Let's check that out. Can't join right now. Okay, awesome. Well, we're very happy to have you, Erin. And so, Virja, what I was going to ask is, um, I was going to ask Aaron if that time that they have to wait before opening is the same, and if their threshold is the same as you all. Now, CFHT and Gemini are on the same eastern ridge near the summit of Maunakea. So I was just curious if you know whether your threshold for opening when it comes to humidity is the same or close to Gemini's.
I'm not aware of what's the limit for Gemini.
I don't remember offhand either. Okay. Okay, no worries, no worries. But
Yes,
I would assume that everybody, all of the observatories have their own thresholds, and the position on the summit, especially on the western side, I know it's a little bit different, because I've seen some observatories like Gemini closed while Keck or Subaru are open.
yes, yes. So it also depends upon, although there are, the observatories are, some of them are at similar locations on the summit, there are also localized, conditions. So even though, I would add, like, even though the humidity is 80 to 85% or below 80 to 85%, even then, we have to make an assessment of how, things look like just on top of the dome where the telescope is opening up before making a decision of whether we can go ahead. And I saw a message from Erin saying that the threshold is 45 minutes, at least 45 minutes below 75% relative humidity.
Ah, okay. So that's the Gemini threshold. Wonderful.
Yes.
Oh,
And
and
we have Jasmine walking.
Jasmine.
So would you
Welcome,
like to introduce
Jasmine, our
yourself?
remote observer for this evening.
A remote observer. So, like you were talking about, now's the time I come in and look at conditions and decide if we can do anything today. Um, so you have these cameras open. Let's check.
Yes, I can share. I have. I'll share another screen that is showing
Yes.
one of the camera views. Oh, this is our okay.
It's a little bit thinner last night. You couldn't really see.
Okay.
No,
This is what we are seeing at our end right now.
Oh, that's a much better view. Thank you.
So whenever Jasmine is ready to tell us about what we can make of the conditions and what we will be doing in the next few minutes. Till then, I can share a little bit about the CFHT as an observatory. We are a 3.6 meter diameter telescope, so it's relatively small compared to something like Gemini, which is an 8 meter class telescope. But there is a range of science that we can still do with a 3.6 meter. And the range of science comes from all the different instruments that we have at our end. We have 5 different instruments. There are 2 imaging cameras. One is in the optical and one is in the near infrared. We have 2 different spectropolarimeters. So those actually take spectra of objects. A spectra is basically the full range, the energy range that we can see for different objects. And the energy range is basically different colors, not just the visible range, but also the wavelengths that we cannot see by our eyes, which is in the ultraviolet and the infrared. So that basically gives us a range of the light in a range of different energies. So we have spectropolarimeters, one in the optical, one in the infrared, and we have a spectroimager, which is basically taking both images as well as spectra. What we have right now, unlike Gemini can switch between different instruments
Yes.
during a single night. At CFHT, we are not able to do that. We are quite an old facility that way. So what we do is one instrument at a time. There is a stretch of one instrument run, which can go anywhere between, say, around 5 nights to 15 nights. And what we have right now on Sky is a MegaCam. So MegaCam is our optical imager. We basically observe at different energies, but all in the visible range. So in green light, red light, blue light, there are different ranges over there of blue colors and red colors. So it's our optical imager. It's a wide field camera. And by wide field, I mean it looks at a patch of the sky, which is 1 square degree by 1 square degree. And that's pretty wide in astronomical terms. So before I go any further, Jasmine, do you want to share what we're seeing right now and what do you assess of the conditions?
Yes, do please give us your insights, Jasmine.
So I have a pretty bad assessment. The steps that I go through are. I should show this on that TV. Well, there's this tech cloud cams that I think that Jessica actually left open on here. That's okay. Open it on here for sure.
While they are doing that, I'd like to thank all of you for introducing yourselves in the chat and for letting us know where you're from. We have an audience from all around the world, from LA to South Africa, India, Memphis stargazers. We have Hyderabad, Bangalore. Fairfield, California. It's just great to have all of you here. Thank you so much for joining us. And again, your comments and questions are welcome in the chat anytime. Now, we have these amazing experts with us, and this is live observing. So nothing is prepared ahead of time. There's no presentations. This is actually what's happening. And of course, we know with anything that you do outside, you're going to be subjected to the weather conditions. And right now, things are atypical. This is not the case for many evenings on Mauna Kea. We have a very high rate of clear skies and really, really good seeing. So Jasmine or Virja, one of you or both could maybe give us some insights there. How often do you come across nights like this?
That's a great question. It really depends upon it's not the same all the time. It varies throughout the year. Mostly winter times could be harsher. Generally, when there are thunderstorms, when there are uh, when the Pacific Ocean has a lot of storms coming in, then those are the times when it's very tricky and weather can get really bad. So we lose most of the nights during that time. And this is one such night, but otherwise during clear nights, we do get a lot of clear nights. That proportion is much higher when we're able to do really good observing. So I would also like to welcome everyone first on the call. It's really great to have audience from all over the world. And we have right now Jasmine. She'll share the status of what's happening right now.
Perfect.
Can you share the screen?
Yeah, I think is the screen shared for you guys?
No,
Oh, okay.
I've connected
Sorry.
again on the RO computer, so you might
Please
want
feel free to share with us.
to
And
just.
I'd like to just quickly jump in and say thank you, students from the Akaula School on Molokai, for joining us. I know that you have to leave right now. Thank you, Ms. Newberry. We look forward to having you and your brilliant students in our session again. Aloha.
Or maybe over there, the top. That's interesting.
Welcome, Steve from Santa Cruz. I was just in Santa Cruz last week, Steve. Aaron, who is actively, I believe, maybe not active right now, but Aaron is an observer at Gemini Observatory, and Aaron's just put in the chat that they love seeing the Gemini status page with their cloud cam looping in the background. Yes, 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 Aaron. Jasmine Virja, is there something
Yes.
on my end that I can do for you?
No, we're trying to see how we can share. Oh, wait.
Screen.
Maybe no, I've stopped sharing. So we're having some issue trying to share the screen. We're just checking how we can do that.
Sure, absolutely. While you're doing that, I'd like to say aloha to those joining us from the Maunakea Visitor Information Station. It is great to have you. Shout out to Adrian for getting this set up. Thank you so much. I'm so grateful to collaborate with the amazing staff, the amazing Viz staff. I look forward to joining you all.
Oh,
Hopefully,
here, I got it.
okay, wonderful.
We're going to do
We
this,
got
right?
multiple can share. Okay.
Okay, I think they're seeing the right one.
Yes, so you guys can see this now.
Yes, we sure can. It says up cloud camera.
So this is kind of what the weather looks like outside right now. So in these kind of conditions, we are likely not going to open starting the night, but it at least isn't fully covered. You can see some of this fog here starting to drop down. It's often that after sunset, fog events like this will settle down due to the air cooling. Here you can see above head 2, and then on this west cloud cam, just a bit more tumultuous. So anybody can go to these web pages to look at this on your own. If you look up Google Gemini North Status 2005, or that link that's up there, you can visit this website anytime. We also have, just based on that, I want to check the weather forecast, which I know is bad. But when you look at the weather forecast, it confirms for us that these conditions we are seeing are forecast, they're predicted, they're not just random fog coming out of nowhere, which we sometimes see. So on this bar, these tells us the chance of fog and the chance of precipitation for a given window. For this evening, it's showing 100% chance of fog and an 80% chance of precipitation.
That is a lot of red, a lot of red.
And then this next bar shows us cloud coverage and then how high the cloud coverage is going to be. So there's also going to be about 100% cloud coverage above as well. So even if we have periods that this fog might clear, I still might decide to stay closed if I think more fog is going to come, or if we aren't getting any kind of good data. So there's some of the weather stuff. Before we move on, does anybody else have any questions about weather on Mauna Kea?
I'm checking the chat really quickly. I don't see any other questions right now
Well,
about the weather.
especially now, since I'm not opening the telescope at this time, we can talk a little bit more about a lot of different things.
Okay.
So there's one thing that I would like to know.
Mhm.
So when there are conditions like this, what can we expect happening inside the observatory in the dome room where the telescope is located?
Yeah,
Oh, yeah.
here at the telescope.
At the telescope.
At the summit, it just stays parked and off, has this protection from the wind. The only thing sometimes is that the dome can get blown around by wind. And if it rains a lot, we can get puddling of rain on the ground. So before a big storm, so that we can prevent this rain buildup on any of our important equipment, we rotate the dome ahead of time just to an area where MegaCam or something else that's important isn't stored.
Oh, I see. I see. Okay. And then so is that something that has already been done for this evening?
For tonight, I think it's just foggy. It's okay. It's not icy. So if it started to really precipitate, I would worry about it. But with just the fog, I think it's okay. So I'll
Mm.
wait to see if I open it. We do something called pre-observing checks a little bit later, like if it's about been 30 minutes past you want to open, but you can't, you'll do pre-observing checks, and we move the dome as part of those checks. Um, but thankfully, let's see if I look at the dome.
Are you looking at a different view of the dome, Jasmine?
Yes, I am.
Can we see that view?
Yeah, I could get there. Give me one
Thank
second after I
you.
turn the lights on.
Okay, I'll share the other screen. I'll stop sharing this.
Okay, and you can do the
And
checks.
yeah, I can just share it on my end.
Okay. Teamwork.
There we go.
Perfect. So this is what it looks like inside the telescope. This one is just our main floor. The little bins on the floor are there to capture hydraulic fluid that might come from slewing the telescope, especially to low angles.
What hydraulic fluid?
Yes.
Is the hydraulic fluid, is it corrosive or could it damage anything if it's not caught in those containers?
It's pretty light. I think it's mostly for the safety of the telescope.
Definitely.
And like the people working in the telescope, it's a very slippery material. Very oily, so
Right. So now this is a live view inside of the CFHT dome. Now, how many people get to see this view?
So this is inside. You can see the lights are on, so we can actually get a view of what's inside the dome room, which is the 5th floor of the observatory. The telescope is right now in a parked position, so it's pointing straight up.
so I'm gonna point so we can see the very top of the telescope, MegaCam. If you go to the West View PTC camera.
This
Yep. Oh yeah, there it is. That's the top of MegaCam near the top of the dome. This one shows our mirror covers in the dome. When they're closed, they protect the mirror from imperfections, dirt, etc. on the dome. But they're also helpful for like during storms, if ice is falling through the dome, or if people are working on the primary mirror and don't want any damage on the dome. Because the primary mirror is not something that is easy to replace. Here, these I will not be using tonight. I wonder if I can use here. Are the dome vents on the top side?
Oh, yes, the dome vents. Does that help to equalize the pressure and the air?
Yeah, usually it's really helpful to balance the air temperature, the turbulence in the atmosphere, stuff like that. On a nice night, we use them every day that we can. And it just happens that right now, of course, we will not be using vents, but you can see here that there is 16. There should be 16 operable vents at a given time. 10 at a given time, but one is down. So we have heard from our scientists and just other studies done about dome seeing over time, just how good, when the conditions allow, when we use these lens, how drastically they can impact the image quality of some images. So we try to use them when we can. But for example, if it's very windy, then the telescope is just succumbed to more motion. You might get worse images and worse image quality because the telescope is getting shaken too much. So we just have to figure out a balance of using the windscreen, using the vents, closing some of the vents as we observe to try to get the best data quality. And if it wasn't foggy outside, I would open them for you.
Well, I I definitely believe that you would. We appreciate the special treatment, VIP behind the scenes view of the observatory at night while the dome is closed. So you have this downtime right now, Jasmine. How often are you going to check the conditions to determine whether or not you can open?
I'm pretty hyperactive, vigilant. Usually just do something small in this time, like little tasks, maybe like organize my work projects or something. And watch closely. Like I'll keep good notes about if there's any change, what time it started to change, how long did that change last? Did it just worsen again? So I try to keep pretty good notes, especially on the trends for myself, so that I um especially early in the night, so I can see as the night goes on what percent chance I feel I have to maybe get to do something.
Got
Yes,
it.
that actually gets me to an important point. So, every night when the observers are doing observations, or even if they're not doing observations, there are logs that you maintain. So, can you talk a little bit about what kind of information do you generally include in your logs? One, when there are observing conditions and you're actually taking observations,
Mhm,
and two, in the cases you're not taking observations, but there's still a log that you need to keep
mhm.
about how the conditions are changing or what's happening.
Yeah, so we for the most part, have three kind of weather logs that are important for us to check through the night. The first one is just all the exposures that have come in. And especially on a night like yesterday or tonight, there's going to be a lot of exposures that are may not within the qualifying levels that the PI wants. So we go and look at what they need, and if it's borderline and we end up a little bit over the cloud coverage or a little bit over the seeing image quality for them, then we'll retake the picture. Sometimes just keep repeating and keep repeating and keep repeating the same one until something's good when it's borderline. But there's also a certain point when we know we're not going to get any good data that we just pause between trying to get the repeats, pausing, hoping that then the next ones are going to be better once the clouds move through.
Gotcha. Well, thank you for providing some of those insights for us, and we will check back in with you here in just a little bit, Jasmine. Thank you. So, um, since we have a little bit of downtime, I'd love to ask, and I see I have a comment. Oh, actually, a question here. I'm going to copy it and put it in the main chat from Michael Mosby. Just here. This is from Michael, and Michael asks, has CFHT observed Comet 3I ATL? Now, we have had several sessions with observing this comet starting in July, actually, first a Keck session with Dr. Bryce Bolin, and then we had another amazing session with Gemini South, the International Gemini Observatory, and the Gemini South in particular, of those twin telescopes on August 27th. And that session was led by Dr. Karen Meach of the University of Hawaii at Manoa. And so now I assume CFHT has also done some observations of this incredibly rare interstellar visitor. Can you talk to us about that, and can we see some of those images?
Let me just go back and check if we actually performed those observations. I'm not 100% sure, but I can go back and check the logs. So give me some time. I'll get back on that.
Absolutely. And so while you're doing that, thank you so much, Virja. And so, Jasmine, can you tell us a little bit about the archive? I imagine that once you take data, and the scientists get their data, and it's proprietary for a certain amount of time, 6 months, maybe a year, and then it's included in the archive that any one of us here in this session could potentially access. Can you talk to us a little bit about that while I put the link in the chat?
Yeah, of course. So all of our data is hosted through CDC, which I believe is the Canadian
Astronomy Data
Astronomy Data
Center.
Center. And
CADC.
so they there are sorted by project, the institution that observed, the source, and the PI name, PI names, etc. So if you particularly were interested in, like, a while back, people who maybe wanted to do some at-home astronomy on the Orion Nebula or Betelgeuse, you would be able to go back and get information years over years from different observatories to try to put it together and see if you yourself uh, could find some new finding that wasn't written in the research.
Brilliant. So I actually have just pulled up that archive, and I'm going to share my screen because archival data, I know, plays a key role for a lot of students as they are learning to work with data. Maybe they aren't actively submitting proposals to CFHT, where you might run one of their programs, but they're using data where they get from old, surveys conducted maybe recently, but also decades ago, from all kinds of places. And that data really lays the foundation for their experience, before they get into actually having proposals submitted to major telescopes like CFHT. So, can you take us through what we're seeing here, Jasmine?
I will be right back. And then, yes.
Yes, absolutely. Absolutely. So, I'm on the archive, Dr. Katu, and of course CFHT. It's Canada, France, and Hawaii telescope. So a lot of it you have the French as an option here, and I'm just going to click here on the legacy survey. Now CFHT is known for your incredible images. I have probably 4 calendars of CFHT images, because they're absolutely incredible. And let me just see if I can grab this. So I think I'm here at the CFHT Legacy Survey data, but I'll wait for you to give us some guidance on how we can use this resource, because I know for students, it's pretty incredible to have access to this kind of data.
Yes, absolutely. So I was just looking through our logs, and I do not believe we have observations of the comet.
Ah.
Although there was one other target of opportunity target that we had at CFHT a request for. So target of opportunity objects are basically transient objects, so they keep changing in the sky, and because they keep changing, the observations for such targets can be triggered at any point. These objects are mostly neutron stars, or they could be supernovae that are going on and off somewhere in distant galaxies. So we had actually one target of opportunity supernova observation during the August run. So that was our main, that was one of the programs that we were trying to be on top of to get those observations, because these are very time critical observations. And once we get a request for them, we plan to do the observations either on the same night or in the next couple of nights, or however is the requirement of that program. So I believe during the August run, we were occupied with one program that was a timely program. So that was for another target, but it was not the comet. So unfortunately, no images of the comet, but I'll share a few images from MegaCam instrument a little later. But I want to get to the CADC archival search for CFHT data. And let me share my screen.
Yes,
I can,
sharing, that
yeah,
would be great.
Thank
I'll
you.
share my screen.
Welcome back, Jasmine.
Nice. Sorry, I just woke up, had like 2 minutes in bed and then rolled over here, so my brain's a little slow, but I'm
No
glad to
worries.
be here.
We're glad to have you. And as I, continue to point out, this is live. Nothing is pre-prepared at all. We are joining them, shadowing them as they do their job regularly. So we appreciate that you are just getting up, Jasmine, and are thrilled to have you.
Yes,
Okay.
yeah, it's really commendable for the remote observers. Once they are in the observing room, they work for 12 hours straight from 6 p.m. to 6 a.m. and that includes a lot of tasks. And a main thing is to be on top of everything that is happening around the control room, like right from the weather to any communication from any people. If there are things that need to be, if there's some error that is triggered and they have to reach out to people. So all of this is done at CFHT single-handedly by our remote observers during the night. So it's a lot of work, and they have to be very, very vigilant when they have to do every single thing all on their own. So it's really appreciative of the remote observers to do that very efficiently at CFHT. Okay, so I am sharing the Canadian Astronomy Data Center webpage. This is basically a data processing and storage center. It basically gives all the different facilities, like a one-stop shop for everything that you can do with archival data. The Canadian Astronomy Data Center, it's huge. It does not just have CFHT. It has a lot of different observatories, and you can see the list there. It hosts the data for the James Webb Space Telescope, Gemini, CFHT, JCMT. You can recognize some of those names are Maunakea observatories. The Hubble Space Telescope, DAO, this is this is in Victoria, where the Herzberg Center for Research is also located. There are others that are in the list, but it hosts data for a lot of different telescopes. So it's a very big facility that provides the platform to store the data, give access to data for pretty much anyone who is interested in doing astronomy on their own, even, and giving the platform and tools to actually do the data processing. So that is incredible, especially during these days when people are working on collaborative projects. They want to share the software programming space, and CADC gives a platform to do that when you're working with your collaborators on different projects. So if I want to access the data from CFHT, archival data, I'm basically going to click on here. And if we go down, it shows us, it gives some information about proprietary access, and then it gives us links to all the different things that we can access for CADC, at CADC for CFHT. So when I click on CFHT, it brings me to the advanced search page. The advanced search page is basically to search on all the different criteria that you can see over there. I'll start with the first column. I'm not going to go through all of them, but I'll just give an example of where we generally start with. So the first column is giving observation constraints. So if there are specific programs and you know the observation ID of a specific observation that was done, then you can enter the observation ID under observation ID, or you can search by a PI name. So for example, if I am the PI on one of the CFHT programs, and I know I would definitely know that I'm the PI, but if someone else wants to search data, archival data under my program, then they can just enter the PI name under PI name. What that search is basically going to do is it's going to pop up the results on a different page. And I'll show that how it's done for different objects. So that is how we basically search for data. Now, if I want to do an archival search, say for example, I want to pull up some images taken with the MegaCam instrument, which is right now on the telescope. I'm going to look for something down here called additional constraints. So this is basically to narrow down your search, because there are just so many different facilities for which CADC provides access that you do not want billions of pages of data on your laptop. So I would specifically search for CFHT. There are 5 different instruments that I mentioned earlier that CFHT hosts. I am specifically looking for MegaPrime. MegaCam is also known as MegaPrime. MegaPrime is more of an older reference word for MegaCam. So I'll go into MegaPrime, and then the next column that you see is of the filter. So these are specific filters. For example, if you're looking in the optical range of wavelengths, we have a G filter for green light. We have a red filter for, we have an R filter for red light, and so on. So if I go down here, once I select the instrument, it's going to show me all the options for different filters for that instrument. And say, for example, I go and select the G filter for MegaCam. So that's in the green light. And I want to see all kinds of images. I want to see all kinds of data types. These are basically all images. Now I have done a specific selection of the telescope, the instrument, and the filter. Now I do not want all the different objects observed with MegaCam in the 18 or 20 years of its lifetime. So I'll go over here and try to search for a specific target. So let me search for one object. It's a compact groups of galaxies, which is very prominently studied. So I'll go and do a search for SCG 31, I believe.
Can you tell us what HCG stands for? I assume it's some kind of catalog?
Absolutely, yes. It stands for the Hickson Compact Groups Catalog. Hickson was the scientist who actually looked for these objects. And compact groups are basically compact groups of galaxies. So these are more than one galaxies, which are tightly packed. They may be interacting or may not be interacting, or interacting at very low scales. But these are basically interacting galaxies, which you can actually see as a group, entire group in the sky. So HCG 31 is a very popular Hickson compact object group. And let me do a search for that. And I'm sure it's going to give me a lot of results. Oh, wait. That's surprising. Let me go back.
Oh, no.
It should pop up. Let me search for something else. Oh, okay, there we go. So this is another object, HCG 16. It's also another Hickson compact group. So it's a compact group of galaxies. And this basically gives you the data. So you can see there are lots of rows. And if I keep like scrolling down this way, it's going to get me to how many rows there are. I'm not going to go all the way down, but this is a lot of data. HCG 16 is also one other very popularly studied compact group. So if we look at the columns here, there are different columns that give you a lot of different information. RA and DEC are basically the sky coordinates of this particular object. And this is precisely the way we look for different objects and image different fields when we want to point the telescope. So when we want to point the telescope at a particular object, we're basically going to take into account what's the RA and DEC, what are the coordinates of that object, and the telescope is going to slew to that specific target, that specific location in the sky. And
Now,
then it gives yeah, sure, go ahead.
sorry, I was going to say right RA and DEC. This is right ascension and
And
declination.
declination,
Just
right?
wanted to clarify that for our audience, just in case they weren't familiar.
Sure. And then there's a target name, there's a start date. It gives which instrument, it gives which filter we are looking at, and then there are lots of different information in the following columns. Bless you.
Thank you.
Okay, so let me just click on one of the previews. So this is basically giving a preview of the image of the compact group. If you see over here, this is a tile of different CCDs. MegaCam is the way the instrument is structured is there are 40 different CCDs. So every rectangle that you see over here is actually one specific CCD. And when we are looking at images, we actually are looking at these different CCDs. And when we are processing the images in order to produce a final image, we basically want to do the processing on the images and then stitch together all the CCDs to get a final image.
So
Yeah,
if
sure.
we were open right now would be when I would be starting Twilight Flat,
Oh,
but we are not open. As you can see, fog this year. And even if there are thin cirrus in the sky, other thick clouds, and conditions allowed us to be open, we wouldn't get flats then. So no, we just sit and wait and hope that it settles. A lot of the times the fog like this could settle by sunset, but based on the forecast, I think that it's going to be around for most of the night.
Okay,
uh,
pretty bad.
oh,
So just to
thank-
go back a little bit and talk about what and tell a little bit about what Jasmine was talking about is if it were clear, then we would observe, we would do flats. Flats are basically calibration images that we should be taking when we want to get to the stage where we are calibrating our actual science images to make them ready for analysis. I'll talk a little bit about that when I show you some of the flat images from previous nights. But those are basically calibration images that we observe every night before we start the science observations and then every morning after ending the science observation. So there are two times during one single observing night that we have to observe the flats. All right.
we have a question here from
Sure.
Syed. I apologize if I'm mispronouncing your name. The question is, what is a CCD? And I responded that it's a charge couple device, but could you give us a bit more information because all of the instruments, most of the instruments that we see used in our sessions have CCDs as a part of them. So what are they and why are they important?
Sure. I'll stop sharing the screen for a second. There's one last thing I want to share over or mention over here, but I'll come back to that.
Great.
And I'll share, well, I'll actually go back over here. I think I have so this is a CCD, this is the CCD mosaic of MegaCam, and you can see, you can distinctly see the 40 CCDs. So CCDs, as Jamika mentioned, are charged coupled devices. These are basically chips on which the data gets recorded. These chips are put together in a configuration to build a specific instrument. And the specifications of these CCDs depend upon what kind of instrument you want to design. So when we are, so these, and this CCD structure is basically the core of the instrument. when we have the instrument mounted on the telescope, we basically have light falling on the CCD. And when we have light falling on the CCD, that is when the image gets recorded. And that information is passed when we are looking at the information is stored in the file. And when we are looking at the file, we're basically looking at the raw image. And that is why we see those 40 different rectangles in the raw image from MegaCam. Some instruments have CCDs structured differently. It could be a perfect square, or they could be shaped in a circular manner. Most of the instruments have CCDs in rectangular or square shapes. So this is how CCD is. For a scale estimate, size scale estimate, there's a 2 cents coin on the on the bottom left that gives you an idea of what's the size scale of that CCD. So yeah, so that is basically what a CCD instrument is. And I think I can also go to.
I hope that was a answered
Does
your
that answer the
question,
question?
Sayed. Yes, I hope that answered your question, Sayed. And if it didn't, please put a clarifying question there in the chat.
Absolutely,
Yes.
yes. Okay, so let me go back to just show one last thing on the CADC page, and then we can move to CFHT, how CFHT collects light. So just one last thing on this page. Once you are finished with your search, then you can actually download the data on your machine or wherever it is you want to download the data to process it further. You can do it in different formats. So this is in a table format. This is a comma separated variables. This is comma separated entry file. And this is another TSV format. So for example, if I click on this, let me see what happens. This is a huge data set. Okay, so there was a file that was downloaded to my laptop. It was basically an Excel spreadsheet with all the different entries. And that will give you the links to all the different images, and you can have that for your reference. There are different ways in which you can do it. This is not the only way, but this is one of the ways where you can, if there is something that quick that you want to start doing with the archival data, you can just access the data that way. I believe if you click on some of these links, for example, if I scroll a little bit here, you can see this is showing a proposal ID. And this is showing a PI. So if I click, for example, on the name of the PI, what happens with the way this search is structured is if I click on the name of the PI, oh, it's not clickable. Is this clickable? Yes, that is clickable. So when you click on a specific proposal ID on any of the blue links, it's going to pull up all the information related to that specific entry. So if there is a proposal ID and you click on the proposal ID, it's basically going to show you all the observations belonging to that specific proposal ID. So that is one way in which once you find some data and you're interested to look into similar data, then that is one way of doing that. The search is probably taking a long time because there are just a lot of entries from what I clicked. So we don't want to go into that roundabout.
No worries. In fact, we have one participant here in the chat, Annalise, who's joining us from South Africa. and she says that she in fact did use archived and publicly available data, and when she was working on her research, she relied on surveys and publicly available data.
That's excellent. Yes,
Yeah.
one of the many benefits of having surveys, and CFHT had a long time back now. It had a legacy survey. So one of the benefit of having surveys is basically you're collecting information, a lot of data over long time scales, and by long time scales I mean more than 2 years, up to 5 years, or 10 years for some of the big facilities. So when you have data over a very long period of time, this is just, it's an ocean of information, a very rich collection of data that you can do any kind of science pretty much with such data. So surveys are very critical in that way. So yeah, so it's really nice having to use legacy data.
Yeah, and if you're interested about any of the legacy data and you don't understand, you can reach out to us
Yes,
and we can help
absolutely.
you figure out
I can.
what to do with your project.
Sure, I can just, let me stop sharing this and let me navigate you to the CFHT legacy survey page that actually lists, gives you information about the CFHT legacy survey, and where you can find more stuff. So if you are interested in making use of survey data, then CFHT legacy survey still has data which is being used by astronomers around the world. So you can see there are lots of links in here that some of them give you information about, say, which instrument was used. So this mentions this was collected with the optical imaging camera, which is MegaCam. It gives you information about the data release. It gives you information about how you can acknowledge if you make use of the data. If you want to acknowledge in the publications, and how we can do that. And then there is more news on all the different kinds of science that's ongoing with it. And if I'm not sure if you can see the link, but I can just put it in the chat.
Yes, I'm actually about to put it in the chat right
Okay.
now.
Okay,
Um,
sure.
and I'd like to say thank you to Steve for joining. Steve says has to go, but it's very informative. If you're able to rejoin us, that would be amazing. And if not, we'll see you in a future session, Steve. Thank you so much. And
Sure.
here
Thank you,
now
Steve.
is the link.
Yes. Okay, so I would now like to go back to how CFHT actually collects light. So I can show you a few images from inside the observatory. So this is actually an image of the telescope, but it shows down over here a human to scale. So we are really, really tiny in front of the huge telescope. This is the actual telescope. I'll highlight the different parts of the telescope a bit later. What we see on the top or right over here is the MegaCam instrument. It looks like a cylinder of disco lights, but that's basically the instrument that is mounted on top of the telescope. And both our imaging instruments, MegaCam and VirCam, go on top right over here. If we look, okay, so this way, I believe, or do we still have the dome lights on?
Yep, the dome lights on.
Oh, yes, they are. Okay, so just to show, so this is the primary mirror, the 3.6 meter mirror, which is right now covered with the mirror covers. But that's the primary mirror. And if we look at the image over here, then the primary mirror is down over here. You cannot really see it, but it's down over here inside. Let me show you maybe this way. Okay. So this is the white structure that you see, the primary mirror is like right at the center of that structure, which is covered by all the mirror covers right now. So that is over here. And what you see on the top here in this picture, that's the secondary mirror. Secondary mirror is at a location away from the primary mirror. And that is basically once the light is collected by the primary mirror, it gets collimated and goes to the secondary mirror. And then from the secondary, so the secondary mirror stays up there if there are no imaging instruments used. If we have MegaCam, if we have MegaCam mounted on the telescope, then we basically have to remove the primary mirror out, remove the secondary mirror out, and we need to mount MegaCam at the location where the secondary mirror was. So that is called a prime focus, where we do not have the secondary mirror in operation. It's safely stored away. And instead of the secondary mirror, we have an imaging instrument, which is mounted on the top of the telescope. So that is prime focus. Both are imaging instruments. MegaCam and WIRCam operate at prime focus. If we have a spectroscopic instrument, so say, for example, we have Espidon, Spiru, or Sitel, 3 of our spectrographs, then we keep the secondary mirror on there, and we have those instruments at Cassegrain focus. And Cassegrain focus is basically below the primary mirror. So it's right at the bottom of the telescope where we set up the spectroscopic instruments, Spiru, Espidons, or Sitel. So what happens is, if we are observing with spectroscopic instruments, light gets collected by the primary mirror, it reflects onto the secondary, it gets collimated all the way down. If you look at the image over here, there is a hole right over here. So the collimated light goes straight down the hole, and it's going to go to the bottom part of the telescope where we have our spectroscopic instruments. And depending upon which instrument is in operation, it's going to basically collect the light. The same way it's done for MegaCam. There's a detector made up of CCDs. There are detectors appropriately for the spectroscopic instruments, and the images get recorded on those detectors that we can then see using different kinds of software. So that is how spectroscopic lights are collected. Spectroscopic light is collected. If we want to observe with MegaCam, we basically, because MegaCam is right at the top, there is just it's just a two-step process. Light gets collected by the primary mirror, and it gets reflected all to the instrument, and the instrument records the light. That's the simplest way of in which the light gets recorded. And I'll share a video explaining how that happens. So there's no audio. I'll keep narrating as things are moving on. So this is one object which is being observed by CFHT on Earth on Maunakea, and light falls on the primary mirror. It gets reflected to the imager, which is right at the top. Light gets recorded in the detectors, and then as the object moves across in the sky, we are still moving the telescope with the object and keep on collecting light. And from the summit, through the network, it comes down over here to the control room in Waimea. So this is all happening. This all happens live. If we were observing tonight, this is what is basically would have happened, which is not happening right now.
Oh no. So 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 that was really helpful, and is a good segue back to actually what I wanted to bring up was the CCD cameras, the CCD chips again. Now, when you were in the archive initially, you clicked on an image. It was one of those compact galaxies, one of the HCG images, if we could go back to any one of those, I believe we had that first image was the raw image with you could see the individual CCD chips, but the image below I think was had everything stitched together. Can you talk a bit about that process if I'm interpreting it correctly?
Yes. So when we actually collect images, these are raw images, so we can actually see the different CCDs as distinctly. What happens is when we have these images from the telescope, they come with a lot of things that we do not ideally want in the images, and that is and there are different things. First one is we can have cosmic rays appearing on the images. Cosmic rays are basically high energy particles that randomly hit the detector, and these can be anywhere in the images. And if there are cosmic ray hits on the images, they're basically really high values that you can see. So really, really bright pixels that you can make out in your images. You want to get rid of those cosmic ray hits because that data is basically not science data. It's not useful for the science, so we want to clean that up. There are other things that are happening with the images. So images are when we collect light on the detector, there are 40 different detectors over here, and not every detector has the same kind of response. They are actually made very similar to each other. In a perfect world, every detector will be an exact carbon copy of every other detector. But in the real world, it does not happen that way. And there are subtle differences, although the detectors are meant to be pretty much the same. So these differences are something that we need to take into account when we are assessing and processing the images. So this difference in the response from the detector can actually give you a slightly different scales for the images on different detectors. And what we need to understand is how is that response for these different detectors. And that is one of the reasons why we take flat fields. So flat field images, what Jasmine was referring to, are basically images of plain patches of the sky. By plain patches, we do not want to have, say, for example, it's we are taking images during the nighttime. We want to make sure that there are fields that are not crowded with stars. We have almost plain patch of sky. If we are observing while the sun is still setting down, it's not quite set. We do take flats during those twilight times, but even then, we want to make sure that there are no clouds in the way. The conditions are absolutely photometric for taking those flats. Why is that necessary? Is because when we have a plain patch of the sky, the plain patch of the sky is basically like monochromatic light. It is illuminating each of the detectors in the same way. When we know that each of the detectors are illuminated in the same way, we can understand the differences in the responses from those different detectors. And that is one of the corrections that needs to be done on the images before they move to the analysis stage. There was a question, Jamika?
Yes, and it follows perfectly what you just said. So, Sven, I apologize if I mispronounced that your name, but hopefully it's Sven. And the question is, how do you clean up the image data? And you were just leading into some of the things that have to change. Is it done manually or with computers? Mhm.
Yes, great question. Yeah, it is done with software. This is specific astronomical software which is meant for doing data processing, cleaning up of the data, correcting for any irregularities in the data, correcting for bad pixels. For example, what you can see over here, this is an artifact of the detector and not a real astronomical image. So this is not This is not something which is inherent to the source or what is being observed. It is actually an artifact of the detector, and that needs to be corrected. We call it a negative crosstalk. It is basically where there is some interference from two different detectors, the way the light is interfering with two different detectors, and it's resulting in this artifact, which you can see is darker, which basically means there is lower values of counts at those specific pixels, and that needs to be corrected for before we can make use of the image in any meaningful sense. So there are things like that they need to be corrected. Once we correct for all the different irregularities in the images, at that stage we are ready to stitch the images together. And that is when all the images from those 40 detectors are going to be stitched together to form one complete image of whatever it is that we are observing.
I see. Okay, that makes sense. And now Sven has a follow-up question.
Sure.
Are those vertical and horizontal lines also artifacts? So and I hopefully this is correct. You see there's lines, yeah, going through what I assume are targets. Is that yeah, you're so welcome, Sven. Yeah, exactly that, Jasmine Virja. Yeah, what are those?
Yeah, so this is basically a leak in the flux values. So we are observing stars, but they're stars and galaxies in this particular field actually. So you can make out the galaxies over here. This is a star. You can make that out when you actually see the diffraction spikes. I'm not able to zoom in any further, but they're kind of like they're kind of like spikes over here. The very tiny ones, these are galaxies. The very tiny ones could be stars. So the points where we have this is a leak basically when we are observing a very bright target. Because the target is really bright, the flux from the target actually percolates into surrounding pixels, and that is also not desirable. It's not something that you want to have. So, but there could be different fields where the stars are really crowded. There are sometimes some foreground stars which are very, very bright. So stars that are in between the target that you're observing and yourself. Those are foreground objects, and the foreground stars can also be pretty bright. And when there are bright targets, there could be leaks that are observed in this way. So when the astronomers are processing their data, the leaks, I believe, is not something that is corrected by the processing software here at CFHT. If there are images that do have such leaks, generally the astronomers who had requested data, they are aware that their images are going to have bright targets. And that is something that they take care of mostly on their end while they are while they are analyzing their data. Sometimes it could be a problem, especially when there are fields of really crowded stars. There are crowded fields of many stars. But if it is not interfering with their directly with their targets, then it's generally not a problem. Yes, there's a question.
Yes. So, yes, you're so welcome, Sven. Great. That was an excellent response. Yes, thank you, Dr. Katu. And so I'd like to, could you maybe zoom back a little bit? Yes. And so, so we know we're looking in this image for compact galaxies. Where actually is the target here?
That's a great question. I am a little confused about where exactly the target is. I'm not too familiar with the SCG16 compact object group. It's basically, I can actually pull up an image from online though. Just give me a second. Okay. So this is what a Hubble image of HCG 16 looks like. There are 4 different galaxies as it appears, and it's hard to say, for example, if these 2 galaxies are really interacting. These galaxies are definitely interacting. If you look closely at the image, you can see like a faint stream of gas. It's not very obvious, but there is some interaction over here. There are streams. There are streams that I can see over here. Over here, they're pretty faint, but if there are streams like that, it basically shows that there is actually interaction between the different galaxies. There's one other object that I can show. Let me- This is an example of interacting galaxies, and some of the compact groups can look like this, very interacting. These are 4 different galaxies, which are interacting galaxies, and this is where you can very clearly see the stream of gas. The tails that it makes because of the interactions. This is a really interesting piece of information when you are studying compact objects, compact groups. Um, a lot of all the streams are these are basically streams of gas, and that happens when 2 or more galaxies are tidally interacting with each other. What that means is their gravitational fields are interacting, and when the gravitational fields of 2 different galaxies are interacting with each other, gas is what gets stripped off from the galaxies, and that is why you see these huge streams of gas on galactic scales that can that go on in these regions. This specifically is called the Stephan's quintet. There's also an image of Stephan's quintet with a MegaCam, so I'll show that. This is an image of Stephan's quintet with MegaCam, and this as you can see is a very crowded field of galaxies. There are millions of galaxies in this field over here. If you want to spot Stephan's quintet, it's right over here. So this is the Stephan's quintet, what we just looked at, the 4 interacting galaxies. Down over here, what you see in the broader view of this image are all the different galaxies, but the main reason why this image was taken is not to study the bright blobs of galaxies. It was actually to study the diffused gas that you see over here. You can see there's haze of gas on this corner here. There are some streams that you can see right over here. There's some haze over here. So all of this gas is very diffused, meaning it is basically spread out on larger scales. And this is something which is not straightforward to observe with telescopes, because when we are trying to collect light from diffused object, we're not able to collect a lot of photons. So there is a very specific observing mode that we use on MegaCam called the low surface brightness mode. And with the low surface brightness mode, we're basically able to pull out this diffused light structure in such images. So that is a very specific mode which is used to study low surface brightness objects here at CFHT.
Now, I have to say, for me, this is incredible. And as I've said, I have probably 4 of the CFHT calendars, which and for our participants, you can order those from their website. So that was in your Zoom confirmation email. Check out the website, order the calendar. The images are stunning, just like this. Now, as you were describing this, it was you were taking us on this journey, and for me, even though I'm not an artist, I see this almost as a painting. It
It
feels
is.
like a painting.
Um,
Yes, it is. Yeah, it's very thrilling to see a lot of colors in the image. And when we are, I would emphasize that when we are actually observing with the optical light filters, like the G color or the red color filter, those are the true colors of the objects that we are looking at. This, I believe, is built from optical images. So when you see yellow light, when you're looking at a red light, or when you're looking at a green light or a blue light, those are actually true colors from those objects. So that is another very fascinating thing about looking at optical images, composite images, that you can actually make out the different colors, which tell you a whole loads of information about what's happening in the objects.
It, absolutely. I'm going to put a link here to your images of the month. Um,
Sure, I was going to share that. So thank
oh,
you so much, Jamika. Thank you
yeah.
so much for sharing that. Yes, we have image of the month that gets updated every month. There's a whole catalog, and there is an entire archive of what we have been observing. So images from all the past years. So I encourage everyone to go there. You can make your own calendar with CFHT images. But yes, they're incredible to look at. Thank you, Jamika, for sharing that.
Absolutely, absolutely. And so it is, you can look through here and it's just stunning. The detail, the depth, the colors, all of the characteristics, not only of the primary target, like here, the Sombrero Galaxy, but then also all the other galaxies and stars around it. It's just it pulls you in. And so I wanted to make sure to share it after you were just talking about Stefan's quintet. That image is just so beautifully artistic. And I know that CFHT is one of the observatories, that one of the only ones, I think, that actually puts out a calendar with their images. Is there someone else, or is it just CFHT?
Interesting. I'm not aware of that. Are you, Jasmine?
of what?
Is there any other observatory that puts up a calendar of all of its
I don't
images?
think so. At least not like here. Maybe
Um,
I feel like the ESA might have one,
Ah,
the European Space
but
Agency?
I,
But yeah,
yeah,
I'm
I
not
think
aware
here
of
it's
any of the
just us.
Mauna Kea observatories.
okay, I thought so. Well, the images are incredible. Please check those out, you all. And definitely you can get a calendar. Now, Jasmine, I know we're 2 minutes over. Can we do a quick check-in before we close out? What's the weather like? Has it improved?
Okay, let's go back onto this. So share this one down.
Yep.
Share. Share. Okay, so here's our current. Now that it's dark too, you just let's open up the Gemini ones. Gemini.
If you look at the satellite images, we can still see all the water vapor crossing on top of
Yeah.
the big island.
So there's that too. I'll show that next, but you can see now from each view across all the directions, fogs coming in all directions. Our forecast here shows pretty much a 100% chance of fog for the night. So not very, not very promising. At least the winds went down last night. They were getting about 55 knots, which is like 55, a little more than 55 degrees. So a little bit sketchy, but we can look at a few more webcams just to see more live.
This is certainly a very depressing forecast for all the
Yeah.
astronomers.
Oh my gosh. So
Yeah.
what about the people who so you do Q observing, so no one is necessarily going to lose their
Yes.
observing time, which is one of the benefits of Q observing.
Yes, the time can be adjusted on different days depending upon the priorities. But yes, to lose a night, lose an observing night, it never is a good idea.
Yes. So how we do, like Jamaica mentioned, we have Q service observing mode. We didn't always have that. And then there's classical mode of observing that some telescopes have. So when you're in Q observing mode, you apply for your project, you say how many hours you want. That gets approved. You apply for classical observing like through Keck. They say, I like that. You can come here on September 26th.
Right. Right. Oh
And then I
no.
got here, and it's September 26th, and this is what it looks like. Or there's a lot of remote Zoom doing that as well, but it's still their chance to get their data on that day,
Right.
and just gotta go with what you go.
That's right. So
So
it's with that traditional classical observing it mode, whoever has that. So for example, on Keck, like you mentioned, if they have a classical observing time right now, that's not happening and they just lose that time.
yeah,
Absolutely, yes.
they
They
might be
lose their
just
time.
doing engineering time while they wait. And it's
Oh,
nice, like with Q mode, like yesterday, I started the night pretty good. I thought it was nice. Then some two thick clouds came through. Then it thinned out again. And then right when I thought everything was gonna be okay, it got shut down due to the fog. So that would be much harder, I think, in classical mode for them to deal with that. So all good things.
I see. Well, we appreciate all of your insights, Jasmine, and of course, Virja. Also, you're both fantastic, stellar science hosts for this session, and we really appreciate you. Yes. Now, okay, and so first we have in the chat from Rob Johnson, although humidity is 99%,
Yes.
there is a star visible. There is a star visible from the Subaru. So we could
I
check
think
out.
that's the moon.
Oh no. Oh no. Oh no. Okay, that's right. So it's a challenging night. Well, we appreciate being able to shadow you both live. And this is exactly our goal, to really demystify the observing process for everyone and be with you virtually live in real time as you are going through your evening. So I definitely like to thank you all so very much. And Sven says, thank you all so much for another great opportunity to learn. And I very much appreciate all the answers to my questions. I look forward to the next session. Yes, Sven, thank you so much. We look forward to having you back as well in our next session. And we look forward to having all of you with us. Now, in the chat, and I will repost it as well, but I did put a link to our follow-up survey. If you could please take just a moment, should take less than 2 minutes to complete our follow-up survey. Let me put the link there again in the chat. Now, the follow-up survey will help us improve the participant experience and show our funders the importance of the Shadow the Scientist initiative. Thank you so much. Now, when you go choose this session, September 26, 2025, and this is the session is MegaCam Eyes Wide Open on the Sky at the Canada, France, Hawaii telescope. Yes, thank you so much, Sayed, Annalise, Michael, Nikki, Rob, Sven, Violet, everyone at the Visitor Information Station, Vani, thank you so much for joining us. Akaula School, and those of you who joined us earlier, thank you. We appreciate it. And I will leave the last words with you, Dr. Katu.
Thank you so much, Jamika, for carrying forward the session so nicely. Thank you, everyone, for joining. It has been a pleasure to have all of you on the call. Thank you for all the questions. Thank you for staying with us while we're still battling with the weather. So I really appreciate that. And I look forward to having everyone on the next session. Thank you so much. Back to you, Jamika.
We'll look forward to seeing you both again. Jasmine, Virja, we'll see you next month. Aloha.
Yeah.
Aloha.